Hey, Brooke. So here's problem number 7, which is the last one on your homework sheet. So if we go through, we should start with a map. We start with water. It starts here and it ends here. Okay. So we want to put our maximum temperature. We want to put our minimum temperature. This is here. Let me move that. Okay. So this is 120 and this is negative 30. So then it's water, so we got to figure out phase changes, and phase changes occur at 100 degrees. They also occur at 0 degrees. Okay, so then we want to go through, and it starts here. So from here to the phase change, that's going to be Q1. Then it's going to melt. That's Q2. Then the water, liquid water, is going to heat up. That's Q3. Then that water is going to boil. That's another phase change. That's Q4. And then lastly, let's get a different color. Lastly, we're going to get Q5. That's going to meet up here at that 120 degrees, and that's going to be Q5. Okay, now these are how much heat is gained or lost. So it's a sum of all my Q's is equal to question mark, and we're solving for that question mark. So it's just a matter now of going through and saying, well, it's Q1 plus Q2 plus Q3. What color is next? Plus Q4 plus Q5 equals question mark. Or what we're really saying is it's the sum of all my Q's. That's what we're solving for, though. So when we go through, we can look and say, hey, well, what is Q1? It's a temperature change. So our equations that we have here is we have Q is equal to MC delta T, or we have Q is equal to plus or minus M times L. And the reason we use M times L is for a phase change. So here's a phase change, and that's the latent heat of fusion. And then here's another phase change, and then that's the latent heat of vaporization, because this is from solid to liquid, that's latent heat of fusion. From liquid to gas, that's latent heat of vaporization. So you just got to know those, and we can look up those numbers and what those values are from the table that's also provided on this worksheet. So when we go through and we look at Q1, we can then say, is Q1 a temperature change or a phase change? And the answer is it's a temperature change. So because of that, then we can say, well, that's MC delta T. Okay, and then we can say, well, what's Q2? Well, that's a phase change. So it's a plus or minus, and we have to decide, is it the plus or is it the minus? And it's gaining heat, so it's going to be plus. And we've already identified that this is latent heat of fusion. Then we look at Q3, we can see that that is a temperature change, so that's going to be MC delta T. Then Q4 is a phase change, it's going to be still added, this is M times LV. And then last is another temperature change of MC delta T. Now, the thing we got to keep in mind is these all are different substances that have different specific heat values. So this right here, or we could say right here, is ice. So that's the specific heat of ice, and that is 2090 for a C. Okay, right here, the C of liquid water for Q3 is 4,186. And then for Q5, this C, this is for steam. The C is 2010. Okay, so that's each one has its own specific heat. So we just got to keep that in mind. So when we go through and we start plugging in values, it's 3.5. So my mass is 3.5 times the specific heat. And this for Q1 is ice. So it's 2090. 2090 times my change in temperature. Now you got to keep in mind your final temperature of your liquid water, or of your frozen water, is 0. So it's going to be 0 minus a minus 30. Okay, so that's of the ice. So this is a specific heat of ice. This is a change in temperature of ice, and it's only the change of Q1. Then it's going to be mass times the latent heat of fusion for water, and we look that up. It's 333,000. Then we move to the liquid water. This is liquid water. That's Q3. So it's going to be 3.5 times 4186 times my final temperature. Now remember, Q3 stops at 100 and it started at a 0. So it's 100 minus 0. That's my delta T. That's my Q3. And I'm just going to go over here for my Q4. It's 3.5 mass times the latent heat of vaporization, which when we look that up on our table is 2,260,000. And then last is Q5. It's going to be plus 3.5. Now this is the specific heat of steam. So when I look that up again, this is 2010. And it's the final temperature of my steam. So it stops at 120. So that's my final. But it only Q5 starts at 100. So it's going to be 120 minus 100. And that's equal to that question mark. That's what we're solving for. So now it's just a matter of plugging numbers into our calculator. So my Q1 value, which I'll keep in orange, is 3.5 times 2090 times positive 30. This is 219,450. Okay, do my green numbers, which is Q2. My Q2 is going to be 1165500. That's my Q2. Do the pink ones, 3.5 times 4186 times 100 minus 0, so that's 100. That's going to be 1465100. Then we do the blue, Q4, 3.5 times 2010 times 1, oops, I'm sorry, I missed the Q4. Q4 is in the dark blue, so 3.5 times 2,260,600, 791,000. And then my Q5 is 3.5 times 2010 times 120 minus 100, so 20. And that's going to be plus 140,700, which is equal to question mark. Now all we have to do is add this plus this plus this plus this plus this. And when we do that, and we we go through, and what we get is we get the sum of all my Q's equal to 109000750 joules. So 10,900,750 joules. Okay, so the keys to this is there's 5 Q's. Hopefully you got 5 Q's. But remember, Q1 only goes from here to here, so it's negative 30 to 0. Q3 goes from 0 to 100, and Q5 goes from 100 to 120. Then also Q1 is ice with specific heat of 2090. Q3 is liquid water with 4,186 for a specific heat. And Q5 is steam with a specific heat of 2010. So hopefully that helps. If you need some further help, let me know via email.